In this lesson, we are going to be learning about algebraic proofs. So in algebra, you've learned how to solve equations. Basically, what we are going to do now is use various properties of equality in order to complete an algebraic proof. And if you can solve a simple algebraic equation, this is really just formalizing that process. So we're going to talk about, if you take a look here, a total of 9 different properties that can be used in these proofs. Okay, the first is the addition property. This basically says that if you add the same value to both sides of an equation, that the two pieces, the left side and the right side, remain equal and the equation is balanced. So if I have A equals B, then A plus C is equal to B plus C. Just to show you a quick example, we're going to look at a lot of examples too, but just to show you a very quick one. If you had x minus 3 equals 5 as an equation, you learned in algebra that you could add the same value to both sides of the equation in order to isolate the variable. That's basically using the addition property because you added the same thing to both sides. That's all we're doing here. We're adding the same thing to both sides of the equation. All right, similarly, the subtraction property, if A equals B, then A minus C is equal to B minus C. Okay, I bet we could guess the next couple. The multiplication property says if A equals B, then A times C is equal to B times C. Division property, if A equals B, then A divided by C is equal to B divided by C. So those are our 4 main operations when we solve algebraic equations, but there are a few others that you've learned. So if A is equal to B and A plus 6 is equal to 10, then. So substitute means to replace, to plug in. So we could say, for instance, that B plus 6 is equal to 10. We're replacing or substituting in. The distributive property, that's one you learned in algebra, where if you have A times B plus C, that is equal to AB plus AC. All right, the next 3 might be new to you. So the reflexive property is very simple. It just says that anything is equal to itself. And these are all properties of equality. So notice they all have equal signs. Just want to point that out. Symmetric property basically says that you can reverse the two sides of an equation. So if A equals B, then B equals A. And last, the transitive property says if A equals B and B equals C, then A must be equal to C. All right, let's take a look at an example of how this works. It says we can use these properties in a proof to explain the steps to solving an equation. Below, solve the algebraic equation and add each new line to the proof on the right. Justify each step by using one of the properties of equality shown above. So if we had this equation, 4x plus 6 equals 22, the first thing we would do is subtract 6 on both sides. And we would get 4x is equal to 16. So what I'm going to write for statement 2 is that 4x equals 16. And then we're going to think about, well, what property did we use in order to get that statement? Since we subtracted 6 on both sides, or we subtracted something on both sides, that's using the subtraction property. Okay, and we can even specify the subtraction property of equality. Then if I go back to my equation, if I had 4x equals 16, we would divide both sides by 4 to get x equals 4. So statement 3 is going to be x equals 4, and that's using the division property of equality. So again, if you can solve a basic algebraic equation, we're just formalizing it into a proof. All right, let's take a look at some more sample questions. Use your knowledge of algebraic proofs to answer each question. All right, let's take a look at number 1. 3 times x plus 5 is equal to 21. That is our first statement, so we're just going to say that that is given to us. Then it became 3x plus 15 equals 21. So think about what property was used. Basically, the 3 was multiplied against everything in the parentheses. So we could say that this is the distributive property. So if I had 3x plus 15 equals 21 and I was solving that, my next step would have been subtract 15 on both sides. And I would have gotten 3x is equal to 6. So since I subtracted on both sides, this is the subtraction property of equality. And last, think about how would I go from 3x plus 6 in order to get x equals 2. I would have divided both sides by 3. So reason 4 is the division property of equality. All right, let's take a look at another one. We're going to fill the reasons in for this algebraic proof as well. All right, number 1, 12 is equal to x over 4 plus 6. That's our given statement. Okay, whatever's just provided to you in the beginning, that's just the given. Okay, then let's try and figure out what was done next. It looks like 6 was subtracted on both sides. And you don't have to fill in these steps here. That's up to you. Just kind of writing that so you guys can see what happened. So since we subtracted, that's our subtraction property of equality. And now let's compare lines 2 and 3. So it was 6 equals x over 4. And now it says 24 equals x. So we can tell that both sides were multiplied by 4. So that's the multiplication property of equality. And then let's look at lines 3 and 4. 3 says 24 equals x. Number 4 says x equals 24. The sides of the equation were reversed, and this was the symmetric property of equality that we saw on the previous page. All right, let's take a look at number 3. So we are going to format the whole proof ourselves now. So we are given that 4x minus 10 is equal to 5x minus 3. If you need to, off to the side or on some scrap paper, you can just solve this equation to help you if you need. I'm just going to start by writing the given. And when you're writing a proof, the given should always be how you start the proof. The proof should be how you end. So at the end, we should solve and get that x equals -7. We just have to show the in-between steps, how to get there, basically. All right, so if I was solving this equation, the first thing I would do is get the variables on the same side as one another. So that would give me -10 equals x minus 3. And I'll just show you in a different color here. That would have been me taking the 4x, moving it to the other side, and that would be the subtraction property. I subtracted on both sides. Okay, so line 2, our reason, subtraction property of equality. All right, so in line 2, we ended up with -10 equals x minus 3. Now I would have gotten the constants on the same side. So when I do that, I would have gotten -7 equals x. And if you need to, you could do it in another color too. I would have added 3 to both sides. That would have given me negative 7 equals x. Since I added to both sides, that's the addition property of equality. And I can actually see here that I'm now done with my proof because I was asked to prove that x equals negative 7. Actually, I have one more line here. Sorry, I take that back. So we proved negative 7 equals x. If we want to prove x equals negative 7, we proved the value was true, but we have to get it formatted the same way. We are going to now use the symmetric property of equality, just like we saw in question 2. And now we have x is equal to negative 7, our proof statement. All right, last sample question, this video here, number 4. Again, we're going to complete a 2-column algebraic proof. So I'm going to start with my given. 4 times 3x plus 4 is equal to negative 8 times 2x plus 5, and reason 1 is that is given to us. If I was solving this equation, the first thing I would do is multiply using the distributive property. That would give me 12x plus 16 equals negative 16x minus 40. And I already said what we did here. That was the distributive property. Similar to the last question, now I would get my variables on the same side as one another. So that would give me 28x plus 16 equals negative 40. I'm choosing to move my variables to the left side of the equation. You could potentially do it the other way, and that would change your reasons throughout. Just want to mention that. So what I did there, I'm just going to go to the blue ink for a second, is I basically added 16x to both sides. So since I added, keyword there, that is the addition property of equality. Let's say you chose to subtract the 12x to the other side, you would be using the subtraction property of equality. So we can prove the same result through slightly different means. That's okay. All right, the next thing I would have done in this proof is move the constants to the same side. So I would have subtracted 16 on both sides. Okay, so I'll show you in the blue what I would have done. And again, there I said subtraction, so this is the subtraction property of equality. And then I would have divided. And when I do that, I get x equals negative 2. So I would have taken that equation, divided by 28. And that's the division property of equality. Now, if I was doing this on a test, what I would probably do is do the equation off to the side, or just kind of take all of this algebraic work out just to keep it nice and formal. So definitely good in there to show your work, but I would formalize it at the end so that it looks like this. In the next lesson, you'll learn how to complete a proof where you're trying to prove ideas about segments and angles.